All right, today I'm going to give a helpful video here for helping you understand recursive descriptions, how to write them and how to read them, how to interpret them. A little bit of groundwork before we jump into our first sequence, and we're going to talk about this notation. When we're looking at a sequence, we know that it's made up of a bunch of terms. And whatever term we happen to be looking at, I don't know if it's the 7th or the 8th or the 18th or the 42nd. We call this the current term or the nth term. Okay, that's the term that we will be focusing on. The n minus 1 means back up one term. Okay, the n minus 1 means we're going to be backing up. Sometimes we call this the previous term. And when I talk about n plus 1, that means please move forward 1 from the nth term. And in English, we'll call this the next term. So when I say next term and previous term, you're going to know what I'm talking about. We're going to use this in writing our descriptions. It'll be very helpful. All right, so here I have part of a sequence. Okay, 11, 14, 17, 20. There's a bunch of terms in front of it, a bunch of terms after it, but this is the part that I see. And we're fairly observant, and we notice, of course, that this all goes up by 3. So I want to describe this pattern. Okay, I'm not describing the sequence, I'm just describing the pattern that I see. And so I'm going to do this by picking a term, any term we want. And I don't, like I said, I don't know what term this is. Okay, if it's the 8th or the 14th or the 118th, I don't know. Okay, so I'm going to call this the nth term. Okay, so it's pretty obvious to me that this pattern says if I want to get to 17, which is the next term, if I want to get to 17, which is the next term, I need to take this nth term and add 3. Adding 3, I didn't want to do that, to the nth term will give me the next term. I can get to 17 pretty easily. And I can do the same thing if I started at 17, add 3, I get to 20. Because somebody else might have said, I don't want to start at 14, I started at 17. Well, you know what? Your pattern is the same. This person who called 17 the nth term and wants to make 20 the n plus 1th term, the next term, move over to the right one, they added 3 as well. Okay? I could also, if I wanted to, say, you know what? This was the nth term. How did we get there? How is it that I got to 17? Well, I took the previous term and added 3. I took the previous term and added 3. That would also give me the nth term. So both of these descriptions are accurate and correct. Okay? I look at the nth term, I add 3, that gets me to the next term. Or I have the nth term, that means I started with the previous term and added 3. All right, let's try this one more time. 5, 10, 20, I'm looking for a pattern. It seems to me that my pattern here is I'm multiplying everything by 2. I don't know what number term this is, so I'm just going to call this the nth term, or this one, it doesn't matter. I can get to the next term, I can get here by multiplying by 2. I take this nth term, I multiply by 2, I get the next term. The cool thing about this description is it doesn't matter where I started in my sequence. I can get to the next term here by multiplying by 2. All right. Sometimes the sequence is a little bit harder to see. Okay, this one's a little bit harder. I added 2, then I added 4, then I added 8. That's going to be really hard to describe that in a pattern. I'm going to look for some other options, and I start thinking, you know, what happens if I multiplied by 2? What happens if I multiply by 2? Well, that's interesting. Let's say I start here. If I multiply by 2, I'm just 1 away from that, right? I can get to the next term by multiplying by 2 and subtracting 1. Is that going to work over here as well? I think so. If I multiply by 2 and subtract 1, I get the next term. Challenging pattern. How about this one down here? We did this one already. Okay. Started with 5, multiply by 2, subtract 1. That gave me that. Next term. Let's take a look here at this pattern. 7, 13, 25. We had 6. We had 12. We had 24. Oh, that's interesting. I keep doubling everything. Doubling everything. Maybe there's something if I double everything. What happens if I double everything? If I start with 13 and double it, it gives me 26. Add 1, that gives me the next term. I take 25 and double it. Subtract 1, that gives me, holy cow. What do I notice about these two sequences? The pattern is exactly the same. Double this, subtract 1. Double this, subtract 1. Double this, subtract 1. Right? Double it, subtract 1, I get 49. Double 5, subtract 1, I get 9. Interesting. So the pattern is not enough information for me to actually determine what my sequence is. What I need to know is, where does this sequence start? Here's the pattern. This pattern is the same. 2 times a sub n minus 1 is a sub n plus 1. And sometimes we put that over here. But in this sequence, I started at 2. Double it, subtract 1. Double it, subtract 1. Double it, subtract 1. Double it, subtract 1. I get all the way out to 17. This one is exactly the same pattern. Oops. But I started at 7/4. And the math on that's a lot harder. 7/4 doubled is 7/2. Subtract 1, I get 5/2. Double 5/2, I get 5. Subtract 1, I get 4. And from there, it's a lot easier. Double 4 is 8. Subtract 1. Double 7 is 14. Subtract 1. 26, subtract 1. 50, subtract 1. So I need both of these pieces of information in order to actually write out my sequence. I need to describe the pattern, and I need to let you know where we're starting, because starting at different spots will result in 2 totally different sequences, even though they can have the same pattern. All right, now let's work backwards. If I give you a starting spot and a pattern, can you find the sequence? All right, well, I'm going to start at 5. And what does my pattern say? My pattern says, if I want the next term, you're looking for the next term, right? We call this the next term. That tells you to take the term you're at, multiply by 3, and add 1. So 5 times 3 is 15, plus 1 is 16. Simple enough. How do I get the next term? Oh yeah, I look at my pattern. To get the next term, start with where you're at, multiply by 3, and add 1. 3 times 16 is 48, plus 1 is 49. To get the next term, start at 49, multiply by 3, add 1. 148. Dot, dot, dot. Okay. Now, we can do this one on our calculator, and I think I've showed most of you in class. So I can quit clear. On my calculator, the most important part here is just these. Okay, I want to make this appear on my calculator, only instead of AN, I'm going to use ANS. Okay, ANS is kind of like where your calculator left off, the previous answer. So I put my 5 in, hit enter. There it is. 5 has been entered. Now I go 3 times second ANS plus 1. And when I hit it, it tells me 16. That matches. Now I just hit enter again. 49. Hit enter again. 148. And of course, at this point, it's a lot easier using my calculator because these numbers get pretty big in a hurry. Make sure you're counting as you press enter because you'll forget what term this is. 108, 256, I might be the 7th or 8th. I didn't count. You should count so you know what term you're on. Now, calculator won't always work, and sometimes these patterns get more and more complex. Okay? This one is telling me the first term is 1, the second term is 3. It's also telling me that in order to get the next term, not only do I have to take the term that I'm at, but I have to use the previous term as well. Okay, so this one goes back 2 terms. So I have 1 and 3. In order to get the next term, I take the nth term, which in our case was 3. This is where I'm at. And add it to the previous term, which is 1. So 1 plus 3 is 4. How do I get the next term? In order to get the next term, take where you're at. And now we're at 4. I'm looking for the next term. That means I'm currently at 4. Okay, so I make this 4. And add the previous term. Previous term to that was 3, and I get 7. 4 plus 7 is 11. 7 plus 11 is 18. 11 plus 18 is 29. And I can continue like that. This one I cannot put in my calculator. We have to do it by hand. When I use the nth term and a previous term, by the way, this is called a second order pattern or a second order recurrence relation. You don't need to know this vocab, but I'm showing you, why this one is different because you have to go back to the nth term and the previous term. So it's a second order. If I had to go back even one more, that would be a third order, etc. Okay, and then I would need 3 starting terms to do that. All right, here's another one where the calculator won't help. This time we have 3. It's a nice place to start. And let's take a look at what my pattern says here. In order to find the nth term, okay, in order to find this term, I'm looking for 2 times the previous term plus n. That's interesting. Not the nth term, n. So in order to find this term here, this nth term, I take 2 times the previous term, 2 times 3, plus n. Well, what term am I looking for? If I'm looking for the second term, then n is 2. So I go 2 times 3 plus 2 is 8. It's a little confusing. Let's try this again. Okay. In order to find the third term, give myself some space here. Move. In order to find the third term, okay, I'm going to go 2 times the previous term, 2 times 8, plus, what term am I looking for? 3. That must be 19. Wow. That's pretty convoluted, okay? A lot of stuff going on here. When they ask you to plug in the 3, okay, more vocab that you may never see again, but I'm just sharing. This is called a non-homogeneous recurrence relation. Okay, The non-homogeneous part means we're mixing our n's with our references to previous terms. If I just have previous terms, that's called a homogeneous recurrence relation. This has previous terms plus n itself. All right, let's give you a practice. Actually, before I do that, I'm going to show you one more thing with this. Sometimes this gets really hard to follow. So I'm going to give you a trick to use. Hopefully that will make this easier. I'm going to make a table. Okay, I'm going to make this table right here. Okay, and over here I'm going to put n. Now, we know the first term already. I want the second, third, fourth, fifth. I want to find the first 5 terms. All right, let's rewrite this statement with n being 2. A sub 2 equals 2 times a sub, let's see, 2 minus 1 is 1, plus, what was n? 2. Don't get excited. Finish the table first. Okay? A sub 3 is 2 times a sub 2. I'm just plugging 3 into each of these. Okay? A sub 3, 2 times a sub 2, plus 3. Now I'm going to do it again. This time with the 4. I get a sub 4 is 2 times a sub 3 plus 4. And now we start to see the pattern here in the numbers too, which makes this next one even easier. I think it's going to be a sub 5 is 2 times a sub 4 plus 5. All right, now that my table is complete, I am ready to go. I put in 3 here. 2 times 3 plus 2 is 8. Awesome, because then this 8 can go here. 2 times 8 is 16, plus 3 is 19. Now I can take the 19 and plug it in here. 2 times 19 is 38, plus 4 is 42. And I can take my 42 and plug it in here. 2 times 42 is 84, plus 5 is 89. So now I have my sequence. Okay, put this all together. 3, 8, 19, 42, 89. Dot, dot, dot. All right, we've got 2 practice problems here for you. Start with our first one. Write a recursive description. I might put this on a Zaption and have you break right here. And then now I'm going to give you the answer and how we do this. I noticed some things here in the middle. 3, 4, 9, 64. I'm looking for a pattern in here. It's adding 1, adding 5, adding a lot, 55, adding 3,965. That doesn't seem like I'm adding anything. Multiplying, multiply by 2, add 1. That pattern doesn't follow. So I'm just thinking in my head, and I'm looking at this. This is 2 squared, and this is 3 squared, and this is 8 squared. 8 squared. Let's see if that helps. What is 3969? I get my calculator and I take the square root and I find out that that is 63 squared. Oh, that's interesting. 64, 9, 4, 2. I think I see a pattern here. I take 1 away from this number and then square it. So how the heck am I going to describe this pattern? How can I describe this? Let's say I'm starting here in the middle. This is a sub n. Whoops, a sub n. And I'm looking for the next term. I want to get to 64. So what did we do to a sub n? I took this 9. I have to make it into an 8. So I take a sub n, I subtract 1. That gives me my 8. Then I square that. And I'm pretty sure that gives me my next term. So the next term is the nth term minus 1 squared. That gives me a sub n plus 1. Now, if I want to write this out, remember that's just the pattern. That doesn't describe this sequence exactly. I could have other sequences that follow this pattern, but I want this specific sequence exactly, which starts at 3. So I put these two things together, and now I have my recursive description. Interesting. All right, practice number 2. Find the first 5 terms. Holy cow, this is 2, 1. I got all sorts of stuff going on here. This is a non-homogeneous because it has a K, and it's second order because it goes back 2. This is a non-homogeneous second order recurrence relation. Yowza. Hopefully we won't have too many of these on the test. Maybe 1 or 2. All right, so let's see what we got. I got to make a table. Let's move this up here so I have space for my table. Oh, bad spot. I'll put it on the equal sign. Put it over here. And I've got K. All right, so I want to find the third term. So I think for a minute, if I want to find the third term, then K is going to be 1. Okay, don't start with 3, because when I put the 3 in, that'll give me the 5th term. Start with 1, because I want the third term. So I'm put a 1 in all these spots. A sub 3 equals A sub 2 plus A sub 1 over 2 plus 1 plus 1. Okay, now I'm going to have K equals 2 and put a 2 in all these spots. A sub 4 equals A sub 3 plus A sub 2 all over 2 plus 2 plus 1. 3 gives me, let's see if I can do this by looking at the pattern now. A sub 5, 3, 4, 5. It's A sub 2, A sub 4, 2, 3, 4. Plus A sub 1, A sub 2, A sub 3 over 2. Plus 1, 2, 3. Plus 1, 1, 1. That 1 stays the same. How many terms am I looking for? The first 5, and that would get me to the 5. So now let's plug in my values. In order to get the third term, I need to know the first and the third term. I'm going to put a 1 and a negative 3 in. 1's going to go in here for the first term, negative 3. Whoops, did that backwards. Negative 1 and positive 3. Negative 1 and positive 3. It's hard to see because I get too many things in my view. Get this practice out of the way. Get this out of the way. Now I can see some numbers. All right, negative 1 plus 3 is negative 4 over 2 is negative 2 plus 1 plus, oh, wait a minute, I changed something. It's positive 3. Negative 1 plus 3 is 2 over 2. 1 plus 1 is 3. Interesting. So now I plug the two 3's in. 3 plus 3 over 2 is 6 over 2 is 3. 4, 5, 6. That gives me a 6. And now I take my 6 goes here, that's A4, and 3 goes here, that's A3. 6 plus 3 is 9 over 2, it's 4.5 plus 3 plus 1 is 8.5. Okay? All right, I'm not trying to scare you with this example. This is where we want to get to. You're going to have plenty of time to practice. Okay, lots of simpler ones, but our goal eventually is to be able to handle these types of situations when we're given really complex recursive descriptions. We can pull out our sequence. Okay, thanks for watching today, and good luck in math class.